This is the sample statistics of the bag weight of year 11 students at CHBC. CHBC is Central Hawke's Bay College, where I teach, and I'm a maths teacher. So this is the sample statistics of boys and girls. So let's read the statistics. The lower quartile for boys and girls are respectively 0.5 and 0.7. Median is 3.53. Upper quartile is 6.1, 5.4. Maximum is 8.3, 7.4. Boys had a sample of 43 students, and girls had a sample of 51. Now, from this statistics, we want to make an inference or decision whether the population of year 11 boys bag weight is greater than or less than the population of the girls in year 11 at CHBC. So basically we've got two population, one of all year 11 students in CHBC and the population for girls in year 11 at CHBC, and we have taken a sample of 43 and 51. Now if there's a difference of sample size, that's not going to affect your decision, because whenever you have a sample over 20 approximately, sample size doesn't make any difference. Okay, you can do an experiment of anything, so you can do this yourself, get the sample bag weight of say students around 20 and then around 40, your decision would not change. Okay, and that's based on a theorem called central limit theorem. Okay, so what I've done is, that's what we want to decide whether we start with the question whether boys carry heavier bags than girls. That's the problem, and this is the statistics, and we want to, so what we can do is, I have drawn the box and whisker of boys and girls. So this is all the data that this is the statistics. So for boys, this is the minimum weight, this is the maximum. That's not important when you're talking about when you're comparing two data. The most important thing is your box. So that's why I didn't write the minimum and maximum here. I'm only looking at the boxes. So when you look at the boxes, you need to look at two things. Okay, so the two things that you need to look at is, I'll write, the first thing is called the shift or the median shift. The first thing is you have to look at the median shift, and second is overlap. So these two things will give you a very clear idea of what you're going to decide. So here, when you look at let's look at overlap. So overlap of boxes. Okay, so when you look at the overlap, can you see for the box of girls completely overlaps boys? So let's write that. So this is analysis. So this is, oops, I need to change color. So this is my analysis, and based on analysis we're going to conclude. So we can say the first thing that you can notice is box of girls, I'll write only G, completely overlaps box of boys. I'll say box B. So what does that mean? That means when you're talking about box, you're talking about the middle 50%. Okay, and that constitute the important data. Okay, so the rest 50% is 25% is to the left of lower quartile, and 25% is to the right of upper quartile. So when you're talking about the middle 50%, basically what we are saying is the middle 50% of girls is almost the same as the middle 50% of boys. That's completely overlapping. So this implies, or this mathematically means, that middle 50% bag weight of girls is almost the same as boys. Almost the same as middle 50% of boys. Middle 50% of boys. Okay, so this is a very crucial decision. Okay, so let me change color. This is a bit difficult to read, so let me make it white. Okay, so what's the next thing that we can see? Okay, so that's one thing. The second thing is, if you look at the median shift, so you're looking at this value. I need to change color. This is 3. This is the median for girls, which is 3, and the median for boys is 3.5. So there is only a second thing that you can say is the median shift. The median shift, or median shift means the difference in the median. So the median shift is only 0.5 kg, and this is not a big difference. Okay, so it's, you can say this is not a big difference. This is not a big difference. Okay, now your answers can vary, answers can change. Some of you may say, well, 0.5 kg is half a kg is a big change. That's fine. Okay, so based on these two things, what can we conclude? So let us write the conclusion. So this is my conclusion. Your conclusion can be different. Okay, if you are concluding differently than what I am concluding, that doesn't make you wrong. But whatever you're concluding should be based on some justification. So here my conclusion is, I'm saying the middle 50% of girls bag weight is almost the same as 50% of boys, and the median shift is only half a kg. Okay, so you can say based on 1 and 2, I'll make it short so you can repeat the same thing, but I don't have the time. So you can say based on 1 and 2, based on 1 and 2 of analysis, based on 1 and 2 of analysis, what should I conclude? I want you to stop and think. Okay, I conclude that back in the population of boys and girls, back in the population of boys and girls, because see, that's what we are doing, boys and girls, because see, from sample statistics we are talking about the population statistics. Okay, we are trying to make sense what would be the population median, or whether this based on this sample statistics, can we talk about the population of boys and girls. So I conclude that back in the population of boys and girls of year 11 students, at CHPC, what should I conclude? So this is the most crucial part. So I would conclude there is no significant difference or major difference, significant difference in their bag weight, or if you want to say in a positive way, we can say they both carry almost the same bag weight, in their bag weight. Hopefully this video has been helpful.